If we have used robustness analysis to get started, we'll know at that point mostly what data there is and where it is and what's connected to what. And we'll know what behaviour there is in total. But we won't yet know which class is responsible for each behaviour. So typically a controller becomes a method, but which object should it become a method of? It may sometimes happen that complex controllers actually become controller objects rather than methods on any particular class. And this depends partly on your technical architecture and platform. It tends not to be something that you can decide purely at the conceptual class level. So we are bleeding into more detailed design at this point. So when you think about allocating behaviour to different objects, the basic fact that's really important to know, and I hope you do, is the idea of how the message flow direction fits with the allocation of behaviour. So an object that receives the message must have an appropriate method, which is to say a method that allows the object to react sensibly to that message, to implement appropriate behaviour. So if I send a message to an object foo that says frobos yourself, then the object foo should actually understand how to frobos itself, which is to say that its class should contain a method frobos. Roughly speaking, that's the way to think about it. The rules of thumb about where methods should go include that behaviour usually lives with the data it works on, and that you should anthropomorphize. So if the object were a person, would it be reasonable to ask it to do that? Does it kind of fit with its general raison d'etre, its general collection of responsibilities in life? I'm being vague because making these decisions is very much a judgment issue. Often it's easy, sometimes it's not. When it's not easy, design principles and patterns can help, and we'll talk about those more later. Once you know how behaviour is allocated between objects, you can record it statically by adding operations to the domain model, or you can record it dynamically by drawing a sequence diagram, and typically you're going to want to do both, and you're going to want to check that those representations are consistent. That, for example, every message that occurs in a sequence diagram actually corresponds to an operation that's in the domain model and is in the correct class in the domain model. Okay, so once we've got our domain classes and they've got both data and behaviour, we are going to have to go on and make some choices about technical architecture and platform and what Java UI framework you're going to use and how you're going to handle persistence and all that kind of stuff. And some of your classes and methods will be dictated by those detailed design decisions. And eventually you can draw real UML sequence diagrams that relate precisely to an implementation, that really describe how messages pass in the eventual implemented system. But should you? Well, that depends on what you're trying to get out of it. General rule for any time you develop a model is you should be thinking, who wants this model built? Why am I building it? Okay? Sometimes you might be building a model in order to clarify your own thought, and that's fine. Sometimes you might be building it in order to communicate something to somebody else at a later date, for example, to pass on to somebody who's going to code the behaviour, or to make available to somebody who might have to maintain the system later on. And so you should be thinking about what it is that the person who is going to be using this diagram is going to need, and whether this diagram is the best way to provide them with that information. There are fundamentally two different ways of using sequence diagrams. You can use it to show example behaviour, so you can use it to show what happens in some particular situation, and it might be a typical situation, it might be a situation that has proved to be problematic, it might just be a situation that for whatever reason you happen to be discussing at the moment. And in that case you're probably going to be very precise. You're going to want to say, supposing we've got these objects in this particular kind of state, okay, and we want to carry out this particular instance of this use case, a particular scenario from this use case. You're not attempting to show complete behaviour of the objects at this point, you're just trying to illustrate a particular example of the behaviour. You can also use it to show complete behaviour. So you can use a sequence diagram to record essentially the whole of a method implementation, for example, and you do that using some of the more sophisticated sequence diagram notations that were introduced in UML2, and you'll see those in some of the background reading. But actually, pseudocode is often easier than a diagram to use for 2, so in my experience 1 is actually much more useful. The important thing is to be clear what it is you're doing, and if it's an example, to say somewhere exactly what the assumptions are. So typically you might put this in a caption in a diagram if it's going into a document, or you might put it in a note, a comment on the diagram, if it's a diagram that's going to be used by people at some later stage. An alternative to robustness analysis is to use CRC cards. And these are another way of getting from an initial understanding of the domain, plus an initial understanding of the requirements, to a solid class model with data and behaviour. So the same thing we were using robustness analysis for. But CRC cards are a bit more responsibility oriented. So in CRC cards, we tend to abstract away from GUI screens and pages entirely, which can be a plus or a minus, depending on where you want to put your focus at the moment. And any time we identify behaviour, we know from the beginning which class that behaviour is associated with, which many people prefer. But really you should know about both of them and try them out, and you'll find in due course which ones you find more useful in practice. So there's some required reading on this, but in brief, CRC cards stands for Class Responsibilities Collaborations, and they were originally introduced by Kent Beck and Ward Cunningham as an aid to get non-OO programmers in that particular company to think objects. So they had a bunch of developers who were very experienced in non-object oriented development, but such people found it quite difficult to learn to think in terms of objects. That's a problem that you may not have experienced because you've probably grown up with the idea of objects as being a natural way to program, but that's an example of how things have changed over the decades. CRC cards can also be useful for validating the chosen set of classes, the class model, against the required behaviour, for example the use case model. Again, they're not a formal part of UML. In fact, they're best thought of as not being formal at all. You probably don't want to preserve the CRC cards themselves as part of your living model that gets passed down through the whole development. As with robustness analysis, I think you probably want to think of CRC cards as being a means to an end. You can, if you wish, record the information from your CRC cards in the class model, but we typically won't. So here are some examples of CRC cards, very simple ones. We've got two here, one representing a class library member, and so this is going to be a class in our system. It's representing a class in the system, it's not representing an actor, okay? But its instances are going to be objects, each of which represents one member of a fictional library, a library in our fictional system. And we showed its responsibilities, and the classes that it chiefly has to collaborate with in order to carry out those responsibilities. And so we're specifying here that part of library member's responsibility is to know what copies are currently borrowed, and in order to do that it's going to have to collaborate with the copy class, and it's going to meet requests to borrow and return copies. So it's maintaining the data about which copies of which books does this library member currently have on loan. And the copy class is going to know which book this particular thing is a copy of, and it's going to be responsible for informing the book class, the corresponding book object I should say, to this copy object, when a copy is borrowed or returned. So the idea presumably is that the book class is going to provide some functionality that's going to say, does there exist any copy at all of this book, which is on the shelf at the moment, because that'll make a difference to the reservation behaviour in the library system. Notice that the copy object does not have a responsibility that involves interacting with the library member. So what we're saying here is that library member depends on copy, but not the other way round. It's going to be library member's responsibility to send messages to copy objects, not the other way round. And so what we're seeing here is that the class, is supposed to be showing a well-chosen name that captures the essence of the class, and you'll revise that as you go through the use case texts and play with the cards in the way we'll cover in a moment. The responsibilities explain what services this class is supposed to provide, and some people like to give that at the level of operations, and other people like to give them at a slightly more abstract level, as I did in the examples there. And you want to be looking for coherence and cohesion among those responsibilities. You want the class to have an unsurprising collection of responsibilities that feel as though they go together. And collaborators explains what services this class is going to need in order to fulfill its responsibilities, and again that might be at a rather more abstract level than simple message passing, and you might even leave the precise protocol of which messages pass undecided. So you might want to say, well, actually I don't know whether this interaction is going to happen via a sequence of 3 different messages, each getting their own return value, or whether it's going to happen by one message being sent and having maybe a more complicated object as its return value, or what. So how do you go about using CRC cards concretely? You have to have some kind of idea of what the requirements are before you start, so that might be a requirements document, it might be a collection of use case texts. They're best used in collections of people, so you have a team of maybe 5 to 6 people, and it's useful to have a domain expert involved, not just the software developers. You want to work in one session with CRC cards on a kind of reasonable sized part of the problem, might be a subsystem, might be a particular use case. You're going to build your conceptual class model by brainstorming possible classes and discussing them and filtering them down until you've got a likely set of candidate classes. And you'll make a physical card for each of those possible classes. And then what you do is you share those classes out between the people. So each person in the group will be responsible for one or more of the classes. And they're going to pretend to be an object of the class as and when an object of that class is required in the interaction. So each person writes the card for the classes that they've been assigned, and they put the name on the front. It's helpful to put a short, precise description on the back, because that tells you whether you're able to write a short, precise description, which is useful to find out. They read out the descriptions to make sure that everyone understands what each class is responsible for. At the beginning, you only add the responsibilities and attributes that are totally obvious. Okay, it's easier to add things later than it is to have to cross things out later. And then you start playing a scenario. So how do you play a scenario? It's useful to have a scribe who's going to describe what happens and make notes of things that need discussion later and all that kind of stuff. Okay. So you're going to pick a scenario, and it might be a kind of inside behaviour, the implementation of some method, how the behaviour of some method is going to get carried out, or it might be a whole scenario from inside a use case, or what have you. You want it to be really specific. Okay, so we're definitely talking about example behaviour here. You might want to consider, for example, what happens when Purditor Stevens, who has no outstanding fines and nothing else on loan, returns using CRC cards by Nancy Wilkinson. That's a nice book on how to use CRC cards, by the way. If you want one, I recommend that one. First thing you have to decide is, where does the initial request come in from the outside? So which domain object is going to have overall responsibility for carrying out this request, involving other objects as necessary? Does that class have an appropriate responsibility already? If not, you have to add one. Now the owner of that class will hold up that card, and they're now pretending to be an appropriate object of that class. Now, if your scenario isn't very well chosen, then you might find that the answer to what's going to happen next is just that this object is going to carry out that responsibility and return the correct answer to the outside entity that wanted this scenario carried out, and there's no more to be done. But you were supposed to have chosen scenarios that involved some collaboration, so more likely it's going to happen that there'll be some logic that goes on inside this object, but at a certain point this object needs some help from some other object to carry out its responsibility. In the eventual system, that's going to mean it has to this object has to send a message to some other object. It has to invoke a method of some other object. So is there already a class that is listed as a collaborator of this class, which has an appropriate responsibility to provide the help that this object needs. Well, if not, that means there's a missing collaborator on this class and or a missing responsibility on the collaborating class, and these things need to be added. Once you've got those things added, then control in the scenario playing process passes to the person who is responsible for that collaborating class. So now they're going to hold up their card, they're going to pretend to be the object that just received the message from the object we started with, and they similarly are going to say, do I understand what I'm doing? Do I have a responsibility for this? Do I know how to carry out that responsibility? Do I just do it, or does it involve me in collaborating, sending a message to some other object, and so on. And so as you go on, you are going to finally get to the point where each object in turn will eventually say, okay, now I've carried out that responsibility, I'm going to return control back to the object that asked me to fulfill that responsibility, because I've done that bit. And maybe that object may in turn then have to collaborate with some other object, and you may carry on with that process with a different collaboration, or maybe it in turn will turn out to have completed its responsibility and will be able to return control up the way. Points to note about this are that you may well find that you have a choice about how to do things, and there's an example that we'll look at in the lab or live session, haven't quite decided. When there's a choice, you should consider trying it both ways in your group, and you may well find that one of them actually makes more sense to you when you try it out. You should expect to make mistakes and need to change things, especially as you start to try to keep the behaviour consistent between your different scenarios, which of course is essential, because eventually you're going to have implemented methods that have to support all of the scenarios that you play. And try to keep things simple, try not to get bogged down in stuff that isn't really helping you at this level. So it's quite straightforward to take a CRC card scenario play out to a sequence diagram. You can record it directly on a sequence diagram, and the logic of what you did in the CRC game takes care of the message direction and causality. You have to be careful if more than one object of the same class is involved, because CRC card processes tend to sort of pun between classes and objects. It's sometimes possible to get yourself confused in situations where one object of a class has to send a message to a different object of the same class, which of course, or indeed simply you have more than one object of the same class involved in the same scenario, which is not uncommon in real life, so make sure that you don't get yourself confused at that point. A few refinements. Some people like to use more than the basic C, R and C, so they might, for example, like to show sub and superclasses, in which case they might be listed under the class's name. Sometimes people like to put more detail, for example, emerging specific attributes on the back of the card. It doesn't usually work to mix up specific attributes and specific methods with the high-level responsibilities on the front of the card, so it's helpful to keep them on a separate part of the card. But you know, there are no rules here, you can do what makes sense in your group. And very often people like to have a concise definition of the concept represented by the class on the back of the card. I think I already mentioned that one actually. There are of course computer-based CRC card tools, you'd expect that. There is actually value in using the physical cards, provided of course you're in a situation where it's possible to meet face to face. So in summary, we discussed here two ways of getting from a clear understanding of the functional requirements of the system, which you have to have at an earlier stage, expressed as use cases, plus a conceptual class model, to the next stage, an allocation of behaviour to the classes that works with both of those things and is consistent with both. And so from your reading and the labs, you now also know how to document that behaviour using sequence, state and activity diagrams.